Welcome to Unit 5, Lesson 4, Representing Functions at Rational Inputs. Let's find how quantities are growing or decaying over fractional intervals of time. So this is going to be important. Fractional intervals of time. So we're going to have to do something with our inputs. So remember what we did in lessons 2, 3, and 4. 2 and 3 with the inputs. Okay, again, B must be bigger than 1 for growth to occur. And if B is bigger than 1 but less than 0, you have decay or depreciation when it comes to money or value of things. Okay, you can read all of this. This talks about half-life and half-life. So when we talk about half-life, our half-life is given. That is our B. So when we write general equations, y equals A times B to the x, our B is going to be 1/2 over some time period. So this is where you have to read the question carefully so that you can understand and put the proper numbers in the proper places. All right, let's look at this problem here. Which of these materials takes the longest to break down? Well, comparing the materials, the half-life of uranium is 704 million years. Obviously, that one takes the longest to break down. So you want to say uranium. Okay, if you had a sample of 8 grams of cobalt 60, so cobalt 60 is here at 5.27 years, how long would it take to break down only 1 gram? Okay, so let's see. So if I had 8 grams and I know half of it breaks down to 4 grams, and then I times it by another half, I get 2 grams, and I times it by another half to get 1 gram. So in 1 gram, I had 1, 2, 3 half-lives. 3 half-lives, L-I-V-E-S, or 3 times 5.27 will give me a little bit over 15 years. 15.81 years. Okay, let's look at the population of Nigeria. In 1990, so let's highlight what we're given. So our first number we're given in 1990, Nigeria had a population of 95.3. By 2000, so that's 10 years, so that we got a decade going on. There are about 122.4 million people. Okay, so decade is our time length. And then we're also given an increase of 28.4%. So what do we have to do with these numbers? So first thing we have to do with exponential functions is write an equation. So 95.3 represents 100%. Increase means plus 28.4%, which gives us 128.4%. But because per literally means divide, and cent means 100, we have to divide this by 100, and this is going to give us 1.284. So I'm going to write that down here, 1.284. This is our B. Why is this our B? Because it must be bigger than 1. We don't put percentages into the calculator for B. You can put percentages for A, but your answer will be a percent. But you don't put them in for B. You need to put real numbers in for B. So now that we have that straightened out, our A is 95.3. So if we say the population as a function of time is 95.3 times 1.284, because we must be bigger than 1. The reason why we add 28.4% to 100% is because we must be bigger than 1 to grow. and then our T stands for 10 years. Okay, now translating our equation from the previous page to here. Express the population of Nigeria, F of D, function as an input of decades and millions of people, D, decades since 1990. So we wrote our equation, but instead of using T for time, we use D for decade, where D stands for decade. Okay, now write an expression to represent the population of Nigeria in 1996. Now, when you had a calculator, if you put this original equation into the calculator, there are two ways to do this. So, we're going to take our F as a function of decades. We take 95.3. We're going to take 1.284. But now we're going to divide our decades by 10. So, if a decade equals 10 years, one decade equals 10 years. If I divide both sides by 10, I get 1/10 of a decade equaling 1 year. So this will give me this. So now what I'm looking for is F of 6. 6 years from 1990 is 95.3 to 1.284 to the 6 over 10. Or if you've already put the original equation, the red equation, not the original, but the red equation into the calculator, you're looking for when x equals 6, because when you divide it by 10, that's 1 year. So x equals 6 means 6 years, and your y will equal something, which is 110.72 million people. This is less than the 122, so it makes sense. Okay, one student said the population of Nigeria grew at a rate of 2.84% every year, because they took the growth rate and divided it by 10. But let's see if that's correct. So if I take our rate, which is 1.284, and I raise it to the 1/10 power to get every year, so this is just dealing with the factors, I get 1.0253. So if I subtract 1, which is 100%, I get 0.0253. Then to go from a number to a percentage, I multiply by 100, I get 2.53%. This is the increased percentage each year. So 2.84, you cannot take your rate over a decade and just divide it by 10. So we found the correct annual growth rate at 2.53%. So reading through the problem, we're talking about half-life. That's our B. 100 grams is our A. And the time is 30 years. So time equals 30 years. A equals 100 grams. That's our start. And B, half-life. That means our B is a half. We translate it into this equation where T stands for 30 years. So now the first thing we do when we read an exponential problem, and how do we know it's exponential? It says half-life. It talks about decay or depreciation or increase or whatever. That's how we know it's exponential. We write our equation and then look at the problems. Okay, so now each of these expressions describes the amount of cesium some years after it's produced. So find the number of years it would take to have that much cesium left. All right, so 1, if T equals 30 years, then 1 equals 1 half-life. This equals 1 half-life, which equals 30 years. Because you stick T in 1, you got 1 full half-life. So now 3, this gives us 3 half-lives, which equals 90 years, because 3 times 30 is 90. So now the next one is 1/30. So 1/30 of a half-life is 1/30 times 30, which equals 1 year. All right, and for the last one is T half-lives. So these are full half-lives, which equals T years. T times 30 t times 30 years. For the top two, I should have probably wrote 1 times 30 and then 3 times 30, so that we're clear that the exponent, if it's a whole number, is a full half-life. So you have to multiply by 30. If it's a fraction, you multiply that fraction by 30. Okay, so now in question 2, they ask us to represent the amount of cesium. So y equals our original amount times 1/2 to the x power, because x stands for 30 years, or y, whatever. But you had to put x's into the calculators. We do not put t's and d's and y's into the calculator. We only put x. Okay, I'm going to ignore B and C because they're the same thing for T 30-year periods. It's the same thing.